the back side of this worksheet, this first question, you're going to need to use your graphing calculator to put it in and try to answer these things. When you enter these equations, make sure on the cosine of pi t over 6, you put this part in parentheses before you subtract the 15.69. Same thing with here on both of them. And you just enter them, and here you're going to have to be in radian mode with your calculator. Otherwise you will, well, you can get the same thing in degree mode, you just have to have a bigger viewing window. Now this, in looking at it, this initial one, the high temperature, it's shifted up 54.33, and this one is shifted up 39.36. So you're going to want to make your Y values, your Y minimum, somewhere around 10, and your Y maximum, since it's going to go up and down from 54, maybe around 80 would be a good maximum. Then this first question asks, what is the period? Well, in all of these, it's pi t times 6, so, and it's dealing with cosine and sine, and both cosine and sine have a period of 2 pi. And then because we have pi over 6 with each one of those, we have to multiply by the reciprocal, which is 6 over pi, and that would get you 12 as the period. Now, this is talking about monthly high temperatures and monthly low temperatures. And just by logic and some common sense, you should have known that the period is going to be 12, because as you've been living, the temperature stays pretty much the same each month from year to year. So that is why we have our period being 12. So then in entering these equations into your calculator, the best thing to do with this, when you do it, is you enter the first equation like so, the second equation like so, and then because it is asking for the difference between the high and the low temps, put a third equation in here and take y1 and subtract y2. I put absolute value around it just in case, but you didn't need to do that. You could just be y1 minus y2. That is this line down here at the bottom. So as we're looking at this one right here is showing the difference between the two. And if you look at it in the table format then, and when you go into table, if you set up your table, turn your independent variable to ask. And then when you get into table, put in the first months, 0, 1, 2, 3, 4, 5, 6. And you'll see here the values for y1 and y2. And then if you add that third equation, you also have y3, which is the subtraction of the two. And so this first question wants to know when will it be the greatest. The second one is when it will be the smallest. So we're going to look at the smallest one first, because that's going to fall in here. As we have the smallest temperature right here at 10.15 in the first month. So this would be January, would be the time of year that the temperatures are the smallest between the high and the low. Then if you take and go back to your x values, and after 6, put 7, 8, 9, 10, 11, and 12. You'll get these values, and if we scroll over and looking at the differences, it goes from 19 down to 10.29. And so then your other ones here, 19.78 is the largest difference. Here the largest difference is 19.69 or 65. So this month would be the one you would want, which is the 7th month of the year, and that is July. And that is how you find those things. Now then, the rest of this side of your practice work shouldn't have really needed to use a calculator for any of these. And when you get to the test, you will get some of these, and that will be on the there will be a no calculator whatsoever part, and questions like this will be on it. Or I may ask it on the calculator part and it's going to be exact values, and so you can't put some decimal piece of crap for an answer. You're going to have to put something with a square root in it for an answer, or whatever you need. This first one, arc cosine of pi over, or square root of 2 over 2, thinking about your circle, and cosine, remember if you're dealing with the inverse cosine, is the top half of your circle, and the square root of 2 over 2 is right there. So that is a 45-degree angle, or pi over 4. Second question says arc sine of 595 degrees. Now, because you have arc sine and sine, basically those two things are inverses of each other and they go away. But you have to understand that the angle we are dealing with is 595 degrees, which going from here all the way to there is 360 degrees. If you continue on, now that's 540 degrees. So 595 degrees is somewhere down there, which this angle here is a 55-degree angle. That would be considered a reference angle because it goes back to the x-axis. Now we're dealing with sine and arc sine, and from our definition of arc sine, we can only deal with angles on the right-hand side of our unit circle. So we have to take this 55-degree angle and flip it over the axis and put it here, where this is 55 degrees from there to there. And so, because these wipe each other out and everything, can't use this angle, we have to flip it over to this one, because sine is negative both here and there. So you're going to say it's a negative 55-degree angle. Next question down says arc tangent, tangent of 130 degrees. Again, arc tangent, tangent are inverses of each other, so they go away. Looking at our unit circle, 130 degrees is somewhere right in there. This reference angle would be 50 degrees. And so arc tangent, we can only deal with angles on the right hand side, just like with sine. So this angle we cannot say 130 is our answer. We have to take, and because we're dealing with tangent, that's like the slope of a line, this tangent is going to be the same in this quadrant, where this angle right here is 50 degrees. And since we're going that way around the circle, our answer is going to be a negative 50 degrees. Number 10 here. Another one, arc cosine and cosine, they're inverses of each other. They can cancel each other out. So you're left with a negative 410 degrees, which on our unit circle, a negative 410 would start here and go all the way to there is a negative 360. And then 50 more degrees would get you to 410. And because we're dealing with cosine, cosine deals with the top half of our circle, and cosine is positive in this quadrant down here, so we need the cosine that's positive in either this quadrant or that quadrant, which is going to be over here, and since this is 50 down, we're going to be talking about a 50-degree angle that's going up, so it's a positive 50. Next question after that, arc tangent, tangent are inverses, so they go away. Looking at our unit circle, 480 degrees negative would be negative 360 and another 120. So that angle from there to there is 120, which makes this angle your reference angle, and that is 60 degrees. Now, arctangent is only the right half of our unit circle. And since we're dealing with tangent, tangent is positive because it's like the slope of a line. So this right here is a positive slope. So we just need to continue on and make that angle up there, which if this angle is 60 degrees, that angle is 60 degrees. Now then, next question, we do not have inverses of each other, so we can't just get rid of both of them. We have arctangent of 3/8 and then sine of that. So here's where we have to refer to our friend, the right triangle. Pick our angle, and let's call it that one. And so if we have arctangent is 3/8, that means the opposite side would be 3. Adjacent would be 8. And now, so that took care of this whole thing. And sine is opposite over hypotenuse. So now we use the Pythagorean theorem, 3 squared plus 8 squared. And that's going to get you the square root of 73. And so then sine is going to be 3 over the square root of 73, which simplifies to 3 square root of 73 over 73. For question 13, same thing. Draw yourself a right triangle. It says our cosine is 3/7, so if this is our angle, that right there is 3, that right there is 7. And now we are going to do tangent of that, so in order to figure out this side, we would take 7 squared minus 3 squared, which that is going to equal square root of 40, or 2 square root of 10. And then so tangent of this angle is going to be opposite 2 square root of 10 over adjacent, which is 3. 14 says arctangent of a negative 2/3. Really don't have to worry about the negative until we're all done with it. So there's our angle, we'll call it theta. And since arctangent is 2/3, this is 2, and that is 3. And now we are dealing with cosine, so we're going to have to find the hypotenuse, which is going to be 2 squared plus 3 squared, and the square root of that, so the square root of 13. Now we are dealing with cosine. And cosine is adjacent over hypotenuse, so 3 over the square root of 13. And then that can be simplified to 3 times the square root of 13 over 13. Now, dealing with the negative sign then, arctangent of a negative value on your unit circle would have to be something down in this area. Because tangent is negative here. It is also negative here, but recall that arctangent can only be an angle on the right-hand side. So we're talking about something in quadrant 4. And in quadrant 4, cosine is positive. So therefore our answer is positive. And finally, secant arcsine of 5/6. One last time and looking at our friend, the right triangle. Arcsine is 5/6, so that means the opposite side would be 5. The hypotenuse would be 6. To find the third side, we would take 6 squared minus 5 squared, which is 11. Square root of 11. And then secant is the reciprocal of cosine, so we would go with 6 over the square root of 11, because cosine is the square root of 11 over 6, so secant is the reciprocal of that, and it's 6 over the square root of 11, and then you can simplify that to 6 times the square root of 11 over 11. And that is the last question on this part of that worksheet.